Hello friends, this is Daniel. I'm the lead developer of the Khronus project, and we want to offer you this time a full course in the management of time in smart contracts. We are going to introduce as well the Khronus TimeCog library, which is a very nice tool that will help you to deal with the issue of time in the smart contracts. So let's get to it. The main concepts that we are going to cover in this little course is how do EVM compatible blockchains that will be Ethereum, Binance Smart Chain, Polygon refer to time. We are going to show you how time works in these blockchains. Then we are going to cover how to get time deltas in native solidity. By time delta, we mean changes of time. Let's say that we want to find what is the current time after we add some days, after we add some months or hours, and how we can do that in native solidity. And then we're going to talk about the TimeCog library, which will make all of that much easier in certain cases where native solidity is not cutting to the chase. I hope that you find this video informative. Let's get to the coding part. Here we are in our remix environment. So we are going to start by opening a new contract that we are going to call time examples.solidity. And we are going to create in this one a very simple smart contract. And I have some little solidity boilerplate here. What we are going to define first is we are going to define a contract. So we're going to call contract time example. And this one, we're going to close it like this. Then inside this contract time example, we're going to define an enum that we're going to call time unit. And this time unit is going to have the following elements. This is just a shorthand to refer to these elements later on, sort of a definition of what they mean. So we're going to define minutes, hours, days, and months. And this is our enum here. We are going to have an empty constructor. So we're going to just call constructor. We don't actually need it, so that's going to be okay. And then we're going to have our first function. We're going to have a function that will give us the current time. And this is the first lesson of working with time in Solidity, is how do we know the current time, right? We're going to have function, and we're going to call it get current time. Is not going to take any parameter. It's going to be an external view function that will return a uint variable that we're going to call current times time. And then let's create our function here. So this one is just going to have this current timestamp is equal to block timestamp. This function will return us the current time, the timestamp that the last block that was produced contains. It might not be totally exact, but it's a very neat approximation, and it's actually quite okay for most use cases. So we're going to compile it, and then we are going to go to deploy it. So we're going to deploy time example. We are going to erase this because it's not something that we need. And then here we have our function get current time. So we call it, and it's getting us this value back. But what the hell is this, right? It's just this thing that we don't know what it is, right? And the time in the blockchain is represented like this. This is what we call a Unix timestamp. Is the number of seconds that have transcurred since the Unix epoch, which it was defined a very long time ago, and that's the 1st of January of 1970. So this is the timestamp. How do we know that this is actually correct, right? We can go to a time explorer that it's here, epoch converter. We can paste this timestamp that this function gave us, and it's converted from machine to human format. And we have it that this is September 10, 2021, which is exactly the time that I'm recording this video, but it's giving me that it corresponds to 3 a.m. in the morning, which is not actually the current time. And this is my current time. It's just this website is translating that one to my current time in my time zone, but the blockchain actually stores these timestamps in the UTC time. It's the Universal Standard Time, which is the time in the meridian of Greenwich in England, which is the meridian 0. So all the time zones are measured against that meridian. So for example, here in Asia, I'm 8 hours ahead of the meridian of Greenwich. In the US, I will be behind. Depending if I'm in the West Coast or in the East Coast, that will tell me how far behind I am. The blockchain stores all the times in this time of Greenwich, in the meridian 0, which we call UTC in computer science. So that's the first thing that we did. So how about we wanted to add some time to this timestamp, right? So we're going to have this function that we're going to call add time. This is going to be external view as well, and it will return also a uint, which is going to be also a timestamp, and we're going to call future timestamp. And this one, we are going to use it to add time to the current block timestamp. So let's take some parameters. Like we want to know how many units of time we want to add and in what dimension they are. And that's the reason we created this enum here. So for this, we are going to work first only with minutes and hours. So we're going to have the following variables here. We're going to have a time unit that we're going to call as time unit here. And we're going to take another variable, which is going to be a uint, which is going to be just units. So for this, we're going to have our future timestamp is going to be equal, and then here is what we're going to do. If the time unit is equal to time unit minutes, then this result has to be, and this question mark is just to evaluate this logical statement that we have here. And if it's true, we are going to do what we are going to write here. We are going to have our block timestamp plus our units multiplied by the number of seconds in 1 minute. So this is a constant that Solidity offers out of the box, the constant minutes, and this is the number of seconds in 1 minute. So it's 60. So we're going to multiply our units by the number of seconds in 1 minute. That will give us the quantity that we need to add here to our block timestamp in case the user wants to add time unit of minute. If this is not the case, since the other one that we are allowing is hours, so we do the following. We are going to multiply by hours around here. And now we have our true statement and our false statement, which is these two, but we want to also be able to check, since we are only allowing the time unit of minute or hour, we are going to require that time unit equal time unit minutes, or, and the way that you write an or in Solidity is like this, time unit equals time unit hours. And this is capital because it's our enum here. And this, we are going to close it, and that's it. So that way we ensure that we are working only with minutes and hours. And we have our function here. So let's compile our contract again. And then we are going to have to redeploy it. So we're going to deploy again our time sample. Here we have our contract, and right now we have two functions here. We have our add time units and our get current time. So first we're going to call this get current time, and it's going to give us the current timestamp of the blockchain, and then we're going to add some units. Since the time unit is being represented by an enum, when we call it externally, we cannot write time unit dot minutes or time unit dot hours. We have to represent it with the integer equivalent, which is 0 or 1. So what we are going to do is first we're going to add minutes, right? So let's say that we want to add 30 minutes. So let's do it. We are going to add 0, which is minutes, and we're going to add 30, and we are going to add time, and we got this timestamp right now. So let's check the timestamps right now in our epoch converter here. This is the current time, which is 3:34 in UTC time. But if I take this one, then we have 30 minutes later in UTC time, which is already the 4 a.m. So that's the way it works. It's working correctly. So let's say that we wanted to add hours, right? So we're going to add 1 hour, and let's add time, and this will give us this other timestamp. Remember that what we did here is just switch the time unit that we are requesting from 0, which is minutes, to hours, which is 1. This is a list that is 0, 1, 2, 3. So let's check this other timestamp that we go back, and this is saying that it's in an hour, right? So everything is working fine. We're working with native solidity here. We don't need to use any library yet. But let's say that we want to implement another function. We're going to call this one function add time simple, and we're going to implement another function that we're going to add here that we're going to call add time long. Let's call this one add time short, because minutes and hours are short. Let's say that we want to add long. So this will be adding time units, and this one is going to accept only days or months. If you try to do this one in native solidity here, then that's going to be more complex, because adding days is going to be easy. We can just do add 1 day here as we did for the minutes and hours. But if we wanted to add months, it's not going to work, because not all months have the same length. And that also has to do with what year we are, and if that year is a leap year or not. So how we can implement that logic in our Solidity contract? And the answer is that we don't have to, because this is the moment when the TimeCog library is going to save us a lot of time. So we're going to go to GitHub. And in GitHub, I have the Khronus project organization here. And under Khronus project, there is the Khronus TimeCog library. So we are going to go to the libraries here. We're going to add the Khronus TimeCog, which is a quite extensive library. All of this is dealing with time-related aspects, but in pure formulaic implementation. So the gas expense is not a lot. So for implementing this function that we just declared, we're going to use an import statement here at the beginning, and we're going to paste the TimeCog library that we just got from our GitHub repository. And here we have it, import HTTP GitHub Khronus project Khronus TimeCog library. So we have TimeCog library available here, and now we are going to be able to very easily add days and add months. We could have add days with the function offered by native solidity, but we're going to do it differently right now. So for this, we're going to call Khronus TimeCog, and we're going to have add days. And this days function takes two parameters. One is a timestamp, which we're going to submit here as block timestamp, and the number of days that we want to add, which is units. And that's it, very easy. And then on the other hand, we are going to do the following. If we wanted to have months, then we're just going to add something very similar to the previous one, but instead of add days, we're going to have add months. Here we have to define if it's equal to days, then we're going to have this thing kicking in, and if it's equal to months, we're going to get this one here kicking in. We have our functions here. We can just redeploy our contract. We're going to delete this one that we already deployed, and we're going to deploy another one. Here we have our two functions, add time long and add time short. So let's try to work with them. We're going to work with the add long right now. We're going to add days. So in our little enum here, days is number 2. And let's say that we want to add 5 days. So add time long. We're getting the timestamp here. And let's go to our epoch converter. And here it is 5 days from now, as this is telling me here, and it's September 15. Now let's add months. And this is going to be 3. And let's get the timestamp. And let's just go to evaluate that timestamp right now in our epoch converter. And we have it here in 5 months. It's going to be February 10 and the same date and time. So as you have seen, this implementation is very simple because we use the TimeCog library. If we have done it by hand, it will have been a little bit complicated to add months. Now, something else that we can do with the TimeCog library is actually return a date here instead of the timestamp. So we're going to implement that. We are going to have here, we're going to return future date, but still we will need future timestamp. So we're going to have here as uint future timestamp. And then we are going to define that future date is going to be equal to Khronus TimeCog. And this is not going to be a uint. This has to be a uint array of 5, and that will mean that we have to make it memory. We can go to the documentation. We are going to get a date object. So timestamp to object, this is what we want to do, and we want to get a long one. So we are going to get date object. It's asking for a timestamp and a direction. So the direction is whether the timestamp that we're submitting is positive or negative, because dates before 1970 are going to be negative. But in this case, we just need a very simple one. We just need a positive and submit the timestamp. So it's going to be easy, and we're going to call it get the object. And we're going to submit the future timestamp that we're just getting from the previous logic. And we also need to submit the direction, which according to the Khronus library logic, we submit 0 if this is positive. So that's it. And this is going to return us an array of 5 elements, which will give us the date and the time that corresponds to the unique timestamp that we are getting together here. Let's do it. We are going to have to redeploy our contract again. And here we get it again. So here we're going to do again 3, 5, I think. So we are going to add time long. And we get our answer here. It's going to be a future day of 2022, February 10 at 3:46 UTC, which is actually the date that is happening in 5 months from now, because right now we are in September. This is the way that you can use the Khronus TimeCog library to work with dates in your smart contracts, to work with everything regarding time. The library is in GitHub. I will put the link to the library in the description of this video. I want to also give a shout out to Howard Hignan, who is the person that actually developed all the algorithms in which this library is based. It's a set of very good algorithms that he made public and open source for people to work in low-level development of time-related libraries. I hope that you subscribe to our channel in Khronus project. We are going to continue giving you some tips on how to deal with the issue of time in your smart contracts. Have a good one. See you in our next video. This is Daniel. Happy building.